Let's look at example 3.7. What does it say? The tensile strength of paper used to make grocery bags is an important quality characteristic. It is known that the strength, say X, is normally distributed with mean mu equals 40 pounds per inch square and standard deviation sigma equals 2 pounds per inch square. Denoted X normal distribution symbol is shown with N in parentheses the average comma variance. So the purchaser of the bags requires them to have a strength of at least 35 pounds per inch square. Calculate the probability that bags produced from the paper will meet or exceed the specifications. Okay, let's write the values what we have in the question. Now it is said that our production, the population mu is equal to 40 and the standard deviation is equal to 2, and our customer wants at least 35 pounds per inch square. So please, when you're solving the problems, draw the curve. So the target value is mu is equal to 40, and we would like to know the probability under the curve, the area under the curve, less than or equal to 35. So 35 can be somewhere. So in order for us to find the area under the curve, we need to find the z value. What is our formula for the z value? Z is equal to x bar minus mu all over sigma, and that is 35 minus 40 all over 2, which is minus 2.5. Now let's look at our normal probability table. Here we have only positive values, which means that we have the numbers greater than 0. So this part, we don't have the values less than 0. So in order for us to find the minus 2.5, we will look at plus 2.5. Why? Because the normal distribution is symmetric from the target value from 0. So let's look at 2.5. Z value is here. So it starts from 0 and goes to 3.9. What was our value? 2.5. Let's look at 2.5. The value is 0.99379. So let's write that. So the probability of Z greater than or equal to probability of Z less than or equal to 2.5 is equal to 0.99379. So what does that mean? It means that, let's draw another graph. This value is z equals 0, and we have z equals 2.5 here. So the table gives the area under the curve, and when we read this value from the table, it means that it is the probability of having z less than 2.5. Now, in our example, we wanted to find, let's draw it with another color. We wanted to find this area. Why? Because the customer doesn't buy the values less than 35. So it means that he wants only this area. Do you see any similarity with these graphs? Since this part is, that part is 0.5, so the area under the curve, this goes to positive infinity, so this area is 0.5. Because whole of the area is 1, half of it is 0.5. So this is also 0.5, and this place is just the same as this place. We wanted to find the area under the curve. Actually, this is the area under the curve, since they are symmetric.